Today we are going to see the new chapter. This is the 13th chapter. The name is Surface Areas and Volumes. We already learnt the surface areas and volumes of solids like a cuboid, cube, right circular cylinder, right circular cone and sphere in the previous class 9th standard. In this chapter, we shall discuss problems on conversion of one of these solids into another. Okay. In our day-to-day life, we come across various solids which are combinations of two or more such solids. For example, a conical circus tent with a cylindrical base is a combination of a right circular cylinder and a right circular cone. Also, an ice cream cone is a combination of a cone and a hemisphere. We shall discuss problems on finding surface areas and volumes of such solids. We also come across solids which are a part of a cone. For example, a bucket, a glass tumbler, a friction clutch, etc. These solids are known as frustum of a cone. In the end of this chapter, we shall discuss problems on surface area and volume of a frustum of a cone. Okay, these are the things only we are going to learn in this class. Before that, let's recall the formulas we learnt in the previous class 9th standard. Okay, so what are the formulas we learnt in the surface area and volumes? First, cuboid. This is the shape of the cuboid, you know that, and its volume is length, breadth and height, that is LBH. Okay, it is a lateral surface, means the four-sided, this four side only we call it as lateral surface. Here lateral surface is nothing but base is 2 into L plus B and height you have to multiply it. Okay, so 2 into L plus B into H, that we can write 2H into L plus B. Then total surface area is nothing but all the faces we have to include, add it. So 2 LB plus BH plus HL, 2 into LB plus BH plus HL. This is the cuboid. And cube means all the sides are equal, right? So it has 6 faces. So the volume is a cube, and this lateral surface we have to consider only the vertical portion. Okay, so here the four side vertical portion only we have to include. So the four walls only we have to include. We can name the lateral surface of the cuboid and cube is area of the wall, also we can say area of the four wall also we can say. Okay, so this is 4a square and total surface area is 6a square. Next, right circular cylinder. This volume is base is pi r square and h you have to multiply it. So pi r square h is a volume, and 2 pi r h, this is circumference of the circle is 2 pi r, and h means it is a curved surface area. The lateral we have to call it as a curve for a cylindrical object. Okay, this total surface area, add up all that surfaces. So here 2 pi r h, so this part, this portion and the up and down portion look like a circle. So 2 pi r square we have to add it with that. So 2 pi r, if you take out common, the h plus r comes inside the bracket. So 2 pi r into h plus r. This is the right circular cylinder of its total surface area. And right circular cone, here the volume is 1 by 3 pi r square h. How we got that? It is 1/3 of the cylindrical. Okay, so cylinder volume is pi r square h. So 1/3 of the cylinder is nothing but the cone. So 1/3 of pi r square h is the volume of the cone. And lateral surface area, that means curved surface area, here we have to say that is pi r L. In total surface area, pi r L plus the base is pi r squared. So add up together, pi r you can take out common, so L plus r you will get it in between the bracket. Then sphere, 4 by 3 pi r cube, that is the volume of the sphere. And what is that? Curved surface area, that means curved surface area we can say, that is 4 pi r square. Okay, then the total surface area also 4 pi r square. Got it? The next one is hemisphere is half of the sphere. So half of it everything. So 2 by 3 pi r cube and 2 pi r square. Here 2 pi r square, and the base part is like a circle, that is pi r square we add it. So 3 pi r square totally. Okay, this is we learned in the previous class, that means 9th standard. We have learned all these things. Now we are going to see the combination of the what is that 3D objects, and the formula we are going to derive from this. Okay, let's solve many problems by using that combination of the solids. Okay.